Hello, everyone. Thank you for tuning in to this episode of the Software Plaza podcast. I'm Twain Taylor, editor at Software Plaza, and it's my delight to bring you each week a new conversation with someone who's innovating, who's doing cool stuff with tech. Specifically, we focus on things that are happening in the cloud native computing industry. And we cover different topics from security to software supply chain to observability, things that's happening in AI. But today our focus is going to be data. And we're also going to be talking about, along with data, we're going to be talking about Envoy, which is it's a proxy and it's often used with a service mesh tool like Istio. Uh, but we'll get more details on it in just a bit. But that's kind of the focus of our conversation today. And if you like this conversation, head over to our website at softwareplaza.com or search for us on YouTube, Spotify, iTunes, wherever you listen to your podcasts, and you'll find us. We've done, I think, over 100 conversations like this over the past few years. So there's a lot you can dig into if you find this interesting. With that, let's get started. I have with me Rohit Agrawal, who's the senior staff software engineer at Databricks. So Databricks is quite a name in the space of data analytics. They've been around for a while. They've reached quite a sizable and quite amount of scale that they've reached in the past decade. And so I'm really excited to just hear from Rohit what he's working on at Databricks, what's Databricks' focus these days. And he is most eager to talk about his work with Envoy. He's an open source contributor, so he's very involved with the project, and he's really eager to tell us about that. So I'm really looking forward to the conversation. I think this is going to be very insightful if you're interested in anything data or networking or service mesh, any of that. So listen in. Um, Rohit, great to have you with us. Thanks for joining.
Thank you so much, Twain. Thank you so much for having me here. Yeah, I'm really excited.
All right. Rohit, to get us started, we'd like to just get to know you a bit, before we dive into all of the tech terms and the concepts that we're going to be digging into. So get us started with just your story. How did you get to Databricks, and at Databricks, what do you work on?
Yeah, so I joined Databricks early 2019. There used to
Mhm.
be 3 or 4 people who were working on this layer. We were still operating in a model where we had a monolith that was proxying all the traffic. So that was the first time we thought about an edge proxy, and we can offload things like authentication, rate limiting, everything to that proxy. And I was lucky that when I joined, those efforts were halfway through. So I got to see Envoy early on. The decision was already made, and I'm happy we made that decision that we are going to move to Envoy. And I sort of like started on this journey of open source and then just like learning more about Envoy and all the use cases that Databricks have.
Mhm. Interesting. So moving to Envoy from what? From what? What was before Envoy?
I used to be a full stack engineer, so I was working on ads for a bit before joining Databricks, and I was focusing mainly on the UI parts. So it was like from a product engineer to a infrastructure engineer, and that to like a networking engineer. It was a complete shift. Like it took me a while to wrap my head around all the concepts, what's going on, and I had to do a little bit of reading on like basics, like what TCP is, what are the use cases that we are using, what are the HTTP protocols that we are supporting, and things like that. But it was very interesting.
All right, all right. And what were some of the initial things that got you hooked and got you to feel like, this is something I want to be spending the next few years doing? Could you tell us some of those early moments of like excitement that you experienced?
Yeah, I feel Envoy documentation is very comprehensive and
Hmm.
like it's great as compared to some of the other proxies. I wouldn't name the projects, but then I've seen the documentation not that good. Like it's very hard to make sense of defaults, very hard to make sense of what features are they support and how do I like push those features. When I talk about Envoy, it was very easy for us to get started. And then the
Hmm.
thing that got me hooked is Envoy is very extensible. You can support any use case. There are hooks for it. There are extensions that you can write. I still remember the first
Mm-hmm.
contribution I did back in 2019 was to customize the error code. We had this very specific need that our clients would retry if you give them a specific JSON message. And then Envoy back then was returning a hardcode message, a
Mm-hmm.
hard-coded message. So the first sort of feature request that I put in was to customize that to a JSON message so that our clients could retry the request. It was very easy to get started. There is a great community behind it. So even contributing to it was such a such a great experience. You would create a pull request, and then people were very receptive of the feature. So yeah, I think that just got I got very excited, like learning about the project, learning about the opportunities, and then the way all the documentation, contribution, and everything is set up.
Mm-hmm. Mm-hmm. Yeah, I'm curious to know about the stack that Databricks runs alongside Envoy. What else do you guys use? What does your stack look like? Because that'll really paint a good picture for us to know, okay, this is the context, this is what we're talking about. So tell us a bit about Databricks' infrastructure stack apart from Envoy.
Yeah, no, that's a great question. And then I'll share a little bit of history as well. So, Apache Spark, like the company is founded by the founders of Apache Spark. Spark was written in Scala. And then the primary stack for the company was Scala. Like all our control plane services, some of our data plane services used to be in Scala back in the days. When we first started using Envoy, there was not much customization. We were just using a proxy. The authentication and rate limiting services or some of the upstream services were still written in Scala. But then primarily the proxy coding was done just like as a JSON or YAML configuration. And then if we needed some things that need to be customized, we were using Lua. Lua is another language that Nginx also support. And using the FFI, the foreign function interface, Envoy does support limited Lua. So yes, like we were customizing the proxy using Lua, and then we were just running bare bones Envoy. With time, things got interesting. We started to do a lot more customization, and then we chose to add a sidecar to these proxy, and this sidecar was Scala. So then we adopted a model that every single request would hit this sidecar, and then we'll do all the customization in Scala and then move forward.
Mhm. All right, really interesting. And considering, Databricks is like quite a big organization, what are some of the unique things that you think you experience? You see that Databricks has these unique challenges that are challenges of scale and something that a more larger size organization would experience. Could you share some of those examples?
Yeah, scale is definitely one of the challenges that we are seeing. We want to get the most throughput per core, and then there are projects underway which helps us achieve that. So scale is becoming more and more important. Like when we started, it was like 1,000 QPS, and then now we are talking about millions and billions. So in a short span of time, like in last 5 years or so, we have gotten like tremendous scale. Also, I
Mm-hmm.
think cost is becoming a big factor. How much telemetry you export? Can you do some intelligence based on, you can cut down on what we are not interested in. Like for example, you're probably not interested in successful request, but you wanna log everything that is failing because that's what people might be interested in looking at. So we sample heavily on 200s, but then everything that is failing, we would try to log. Same thing with metrics, like how much telemetry you export. Can we do some aggregation to save cost? So yeah, it's a very I would say it's a very delicate balance between what right amount of telemetry that you have to be able to support your workloads, to be able to like successfully debug if you face any issues, and also the cost. You don't want to like burn down thousands of dollars because you're exporting so much telemetry.
Mm-hmm. Mm-hmm. Yeah, so when it comes to a service mesh, the two big names that come to mind are Istio and Linkerd. Did you consider those as options as well? Did you use them at any point, or what route did you take when it came to like that service mesh decision?
Yeah. So we evaluated Istio very heavily. I don't remember evaluating Linkerd, but then since we were
Mm-hmm.
using Istio, since we were using Envoy, Istio was definitely like one of the things that we were interested in. What
Mm-hmm.
held us back from adopting Istio? The team was very small, and it's still very small team. It was like 4 people back then, and bringing in something as complicated as Istio, you would need like a lot more people to support it. And also a
Mm-hmm.
lot of pieces that Istio offers, certificate management and certificate rotation, a bunch of things Databricks have
Mm-hmm.
in-house. So then it would be a very big shift to throw out those pieces that we have and then replace everything with Istio. So we wanted
Mm-hmm.
to adopt a model that we just do things that we want. Things like endpoint discovery or some of the cluster and route discovery, like some of the things that we get from XDS. And then we made this decision that let's build our own mesh and we can start adding components as we need them.
Okay, okay. Wow, really interesting. Yeah, because Istio can get quite complex, and so I think that was a good decision. But I think that's probably, would you say that's unique to Databricks that you guys, you said, have something in-house for certificate rotation and all of that? Do you think that's something that most organizations wouldn't have, and so you guys had that luxury of doing this in-house?
I would say it depends. It depends on the companies. Like, where are you in your journey to adopt something like Istio? I would say if you are a new company and then you're evaluating service mesh, probably easier to adopt Istio. And then you just build all those components or you get all those components through Istio. You don't even have to like do anything. Versus like if you are a mature company or like halfway through that journey and then you want something like a service mesh, you already have some of these key pieces built out. So then you'll have to evaluate what will it take for us to like throw those pieces out and onboard completely on Istio versus like can we do something in the middle term and not like adopt complete Istio but then bring in the pieces that we need.
Mhm, mhm. All right, all right. I wanted to shift to talk a bit about load balancing, which is really a key thing when we're talking about service mesh and proxies. You've written as well about this on the Databricks blog about a bunch of different topics. But one of the things is this load balancing, and you spoke about bypassing kube proxy limitations. Could you just talk a bit more about just your views on load balancing, some of the things you learned, some of the things you implemented, anything you'd like to share on those lines?
Yeah, so initially when we started rolling out Envoys and then we had like a lot of upstreams, we saw that when you're updating these services, we would do Canary and then the updates would roll out slowly. If you have 20 replicas, maybe it will take like 2 hours, 2.5 hours to roll out everything. I think that's also fast. You can maybe take 4 hours, 5 hours to roll out everything. So as you are bringing the old replicas down and upscaling your new replicas, we would see that all the new connections would stick to one pod. Like there is no even load balancing happening. And yeah, like we had to keep 40-50% headroom in the CPU for us to be able to address the spikes that would come in because you have uneven load balancing. So we wanted to like look for something which is more reactive. Like if on a per request basis you don't want sticky routing, you want to load balance versus like connections, because once you open a connection all the requests will flow through that connection. So we wanted something more even, that on a per request basis you decide like which replica is healthy, which can support more load, and then we'll just like forward the request there rather than doing like a connection based load balancing. So that was the primary factor. We were thinking about cost savings, that we don't have to keep the headrooms. There were a lot of production incidents that were happening because we would overload one pod very heavily versus like the other replicas which would be available to serve the load. So yeah, that was the primary motivation for us to move to something more dynamic. That an Envoy already has XTS. It provides the endpoint discovery. So that was like one of the missing pieces that we thought like we'll get started with. So that was also our way to service mesh.
Mhm, mhm. It's interesting that you mentioned cost savings for the second time in your responses. And I think that kind of talks a bit to, how you guys think about building out this infrastructure that you want to keep costs in mind. I'm curious to know a little bit more in terms of what you learned about costs. Did you start out thinking costs is a factor we should consider always, and you had, a plan to sort of factor in costs at the start itself? Or did you dive in, start building stuff, and then you suddenly realized costs were spiking and you had to do something about it and you went back and, made some, compromises where you could to bring down costs? Tell us about just how you thought about cost savings along this journey.
Another very interesting question. So I would say cost is always top of the mind when we are thinking about new things, we are always considering or factoring in cost. And that was
Mm-hmm.
one more reason why we did not adopted Istio, because one of the concerns were you'll start adding sidecars to all single repli, like all the workloads. And then what about the additional cost? We'll have to like upscale that proxy given on the workloads that those replicas or those production services are supporting. And then, yeah, like cost will go nuts. So that was also one of the things why we did not want it to roll out Istio in its current form. We
Mm-hmm.
adopted a model of we adopted a model of sidecar-less proxying, that we
Okay.
taught our clients to also speak XTS protocol. And I think it's nothing new, like a lot of people in the industry are already doing it. But then we just did not want to attach a sidecar to all our workloads. So we taught
Mm-hmm.
our clients how to do something like EDS, like talk XTS protocol, do endpoint discovery. The key pieces that we were building for Envoy were the same pieces that we would also use if one service is talking to the other service. So if the traffic is coming through Edge, where Envoy is sitting, Envoy would do the same thing. It will talk XDS, go to this endpoint discovery service, try to discover the IP addresses of the workloads, and then load balance the request. And then our clients also started doing the same thing. So that was I would say one more reason like why sidecar was not a good option, and then how we save costs because we didn't have to attach sidecars. The other benefit was we don't have to do this 40% headroom anymore, because for even load balancing, all the replicas were evenly using the even amount of resources in terms of memory and CPU. So we size them better. We don't have to like keep a 40-50% headroom.
Wow. Okay. Interesting. I was just wanting to get more, I mean, to understand clearly what you were just mentioning, which was this option that you mentioned, XTS, is it? Could
Yes.
you tell us
So
more?
yeah, so XDS is nothing but a set of discovery services. So it's a protocol how Envoy and then other gRPC clients can talk to these discovery services and get the resource. So essentially, if you look at Envoy, it's a data plane. And XDS is a way for it to like discover information, like discover routing information, discover about services, discover about the endpoints of those services. X is nothing but a star. You can think like it's just it can be CDS, which is a cluster discovery service. It can be LTS, which is a listener discovery service. In this case, it was an EDS, which is endpoint discovery service.
Okay. Okay. Ah, all right. All right. Interesting. Another interesting idea that you mentioned in your writing is power of two choices, and it's something that Databricks uses as an approach to load balancing. Tell us about this concept. What does it mean in practice, and why did Databricks choose this over other options?
Yeah, I think we just wanted something very simple that would work for us out of the box. We did not want to write a new load balancing policy. P2C works fantastic. Like it would just like try to make a aware decision by randomly picking two replicas or two IPs. It works better than the random load balancing. So yeah, that was the reason that we went with P2C. There, with time, there have been other load balancing policies that got developed in-house. We also blogged about Dicer, which is our stateful load balancer service. It's also open source now. So yeah, I think now we have, with sticky routing, we have more load balancing policies being used. But P2C was already provided by Envoy, very, very easy to get started with. So that was the main decision why we went with P2C.
Could you just explain it in kind of simple words? What is the idea behind P2C?
Yeah, so the idea behind P2C is you randomly pick two IPs and then you just forward load to one. And with historically, it has been proven that if you're making that choice, that if you're picking two options and then picking one, it performs better than just like a purely random load balancing.
Mhm, mhm. Okay, okay, cool. I want to talk a bit about MTLS and security as well. Talk about how some of the decisions you had to make related to that over at Databricks and just some of your learnings related to those areas of service mesh and networking.
Right, yeah. I can talk a little bit about the motivation and then what we did to get there. So we have
Mhm,
a Databricks control plane and a data plane. Data plane is where your
mhm,
workloads are running, the intensive, like it's customer based. And then
mhm,
control plane is where the services are running. From time to time, data plane have to go to control plane to make some requests, like to list the clusters, jobs, like whatever you are doing. The problem
mhm,
was if data plane wants to reach to control plane, we wanted an additional layer of security saying you are actually coming from a data plane cluster. Like that data plane would have a unique identity, and we wanted to assert that you are actually the customer making that request, and you are not just like making that request from your own machine. Um,
Hmm.
it's easy if you're using HTTP because we have envoys on both hands. If you are egressing traffic from a data plane, there is an envoy sitting. If you're ingressing traffic on the control plane, there is an envoy sitting. So you can just, if you're using HTTP, you can just upgrade the traffic to HTTPS, and the egress envoy can do that for you. But if you're using
Hmm.
HTTPS from a client, client is third party or a user written, you don't control that client. If that's using HTTPS, there is no way for you to mark that request and add the certificate. So that's when we started doing tunneling. Like there is a concept of MTLS tunnel where you start a new request, it will be an HTTP request, and then you shove the traffic that is coming from a client as a payload. So basically on the wire between the data plane and control plane, it's a HTTP request. But then if you look at the payload of that request, it's carrying TCP traffic, like it's carrying the HTTPS traffic. So we would get the additional layer of security when, because these two proxies are doing MTLS, and then the proxy on the ingress side can do ACLs based on where this request is coming from, whether I trust this user to make this request. And then there will be a second layer of TLS termination happening with the actual request that the client made, which is nothing but an HTTPS request. So on your ingress side, you're doing two TLS terminations.
All right, all right. I wanted to dig in to ask a little bit more about something you mentioned a little earlier about sidecarless proxy. Talk to us a bit about that, where that idea comes from, why, is it really catching on in the space? Do you see a lot of people going that route now, or do you still see sidecars being the predominant option? Yeah, just I'm also interesting that you mentioned it when it came to cost savings, that the sidecarless proxy is something that help you save costs. What about performance? Was there any hit on performance because of that? Or, did you see any improvement at all? Because maybe, that meant the infrastructure stack became more lightweight because of fewer sidecars or no sidecars. Talk a bit more about just the idea behind sidecarless proxy.
Yeah, so I would say it completely depends on what your like how much responsibility you want your mesh to handle. For example, if you want to handle protocol upgrades, if you want to handle MTLS terminations, sidecars are great. You don't have to like think about from a service perspective, how do I terminate TLS? How do I discover certificates? How do I rotate certificates? How do I think about observability, like all the metrics, all the logs? So maybe sidecar is a very good solution there. But in our case, service is already doing a lot of heavy lifting. The frameworks that we have, they already do, or they know how to rotate the certificates. They know how to do MTLS termination. They have first class support for logging and metrics. There were a few key pieces missing. Like if you're making a request, we don't know how to do load balancing. And we wanted to
Mhm,
tap into the same solution that we built for Envoy. So that was one of the reasons why we wanted a client, like a thick client, which can speak XTS protocol and which can do the same load balancing that our Envoys are doing.
mhm, mhm,
Essentially, like you can also just outsource that to a sidecar if you have one. But in our case, it would have been a very heavy lift to pull a sidecar only to do load balancing and not do anything else. Like it'll be passed through traffic. The only time you're engaging a sidecar is when you're doing load balancing. So then we chose to do thick lines, and then that essentially brought cost savings because you don't have to attach a sidecar to every single container.
mhm, mhm. All right, all right. Yeah, I wanted to get into talking about your open source in just a bit, but one last question to ask about your work with Databricks. I found it interesting that you call your team within Databricks that you're part of as the traffic platform team. I like that term. I've heard platform team, of course, it's really common, but specifically traffic platform team is not common, and that's the first time I'm hearing of it. Very curious to know just how uh, it's different from a regular platform team, and does it overlap with some other team? Maybe tell us a bit more about your team, what you guys do on a day-to-day basis, and why this particular term and why it matters.
Yeah, I still don't know who coined that term, traffic platform. But yeah, I would say it's a part of platform team and then traffic because we literally handle all the traffic. Everything incoming or outgoing which uses this proxy is responsibility of this team. It's a very small team. We have like
Mhm.
15 odd people now, and there are two groups. There is a group that focuses entirely on ingress proxies, and there is another group that focuses on egress because there are different set of
Okay.
features and challenges. And we do have people who do open source because there are a lot of like custom requirements that Databricks has from day to day. But yeah,
Mhm.
like it's very interesting to me as well. I thought like it's natural because you're handling traffic. You call yourself traffic platform. It's
Mhm.
definitely like part of the broader traffic, broader platform umbrella, which has like cloud platform and other teams as well.
Okay. Oh, all right, all right. So you have a broader platform team, and this is part of that.
Yes.
Ah, okay. Interesting. Yeah, the name definitely works. Um, so segueing into open source, so you do a lot of work with Envoy. What are some of the other projects that Databricks contributes to heavily?
Yeah, I would say Envoy is definitely one that we contribute heavily to. There is another thing that we use called Argo. We have Argo rollouts, for example, Argo workflow in the ecosystem. I also a maintainer for Argo rollouts. We use it for canarying. When you're doing the rollouts, you don't want to like roll out everything 100%. You want to roll
Mhm.
out, you want to send traffic, you want to do some canary, and then if everything is looking good, you move forward. Otherwise, you roll back. So we definitely
Mm.
did contribute a lot of features to Argo rollouts as well because we wanted like how to do canary, how can we do this analysis. We wanted something called dry runs that
Right.
if customers or if users internally are writing new rules, how they want to promote things and roll back, they can do a
Mhm.
dry run first because they don't want to promote everything to production from day one. So they can dry run those rules, they can see how they're performing, and then they can graduate them to wet runs.
All right, all right. Yeah, yeah, really interesting. Were you always like were you always Argo users, or did you all move from Flux at some point?
No, I would say like from Kubernetes, when we were moving to gradual rollouts, we did pick Argo as a first choice.
Okay, okay. Yeah. Yeah. And so what's the focus these days? Where do you invest your time, especially when it comes to open source? Like you work with Envoy, you work with Argo. What are some of the, within the project, some of the agendas that are taking your time where you want to invest in what's happening these days?
Yeah, I would say I would invest time, whatever is the business requirement. These days, it's mostly Envoy, given the amount of use cases that we have on Envoy and then the features that we are requiring. So there is this very big shift that we are noticing. We want to get rid of sidecars. Like I talked a little bit about sidecars. They are great. You can write custom logic, but what if you can do something better? You don't even need sidecars. If you can run all that custom code in line inside Envoy, you can save like a one more call from your proxy to the sidecar. It's essentially just like one pipe, one HTTP pipe. It's very
Hmm.
hard to do other parts, like change other parts of Envoy using the same pipe. So
Hmm.
we in communities started working on something called dynamic modules. There are like two, three people. I'm one of the co-authors of these modules. And one thing which is great about these modules is you can use it to write native Rust or Go code and then run it within the proxy. So you don't need a second container. And then again, like killing that second container means you basically start getting 50% more throughput because right now, if you look at one single pod or replica, it's 50-50. Envoy is taking 50% of the cores, and then the Scala sidecar being very resource intensive, taking like 50% or maybe even more. So if we can do
Hmm.
this properly, we can save like I would say 40% or 50% more CPU. We can have more throughput. The internal numbers from POCs have been amazing. So that's one of my focus, try to contribute as much as possible to dynamic modules and then shift our workloads to this new model.
Interesting. And do you find there's enough takers for this idea? Do you find like other contributors from other organizations as well really saying we need this and we want to work with you on this? What's the kind of response you're seeing?
Yeah, response has been fantastic. Like there are a lot of companies out there which were using Wasm or Lua to do customization, and then people are very receptive. Like it's a very good idea given you can just like run things in line, and then Rust is sort of becoming a long language of choice these days. So yeah, we have
Mhm.
gotten a very good feedback. A lot of people are there involved, and then yeah, we are trying to like handle more use cases as companies, as more and more companies are joining the force.
All right, all right. Wow, that's neat. Looking ahead in the next year or so, where do you see the Envoy project headed? And you mentioned, of course, dynamic modules that you're working on, and that's, let's say that's today. That's something in development today and is about to be released. But even thinking beyond this, is there anything else that you could mention that excites you when you think about the future of the product, of the project, something that you're keeping an eye on and that you hope just comes sooner? Could you tell us a bit about that?
Yeah, I'm actually very amazed how good the community is in just like brainstorming new ideas and then seeing those like through and then getting them in production. It has been
Mm,
fantastic set of people that I work with. And then yeah, like I think the focus these days are on making Envoy an AI first proxy. So we are seeing this huge shift in industry that everybody's talking about AI inference and all these new protocols that are coming up, MCPs, A2As. So there is a first class AI support that we are planning in Envoy. It will become like production ready in next couple of months. But yeah,
mm.
like it's amazing to see how quickly we support new protocols. Like somebody was talking about web transports earlier this morning when I read about it. So yeah, like very quick to adopt to new technologies that are coming out there, and then focus is gonna completely be on AI and then how we can handle AI inferences.
Very interesting. If I were to just push you to say, give us a little more details on what this AI first proxy would look like, from the little glimpses that you may have already, what teaser can you give us about what this would look like in practice?
Yeah, so what we are seeing with the AI workloads, like it's a lot of different kind of traffic. Like for example, you want to do a fan out, you get a request, you send it to different models, you aggregate the response, you send it back to the user, you have to count the tokens. Maybe there are more ACLs, like you have to understand what ACLs people are putting, and then you have to like do those ACLs when your workload is getting processed. So all those things will get native support in Envoy very soon.
All right, all right. Neat. Wow. Yeah, that brings us to the close of our conversation. We covered a lot of ground in short time, and it was quite a whirlwind conversation on just a lot of different concepts in the space of Envoy and service mesh and networking, all of that. Uh, to close, Rohit, I was wondering if you could leave us with a thought, for infrastructure engineers who are listening and watching this. What advice would you have to give them as a takeaway, as they think about working with these technologies the way you are? If they, what would you tell them?
Yeah, I would just say one thing, like from my personal experience, this space is very fast moving. So it's very good to keep yourself up to date and then just like be very open to the new ideas. Because, yeah, like if you're not open to the new ideas, maybe 2 years down the line, the stack that you're working on is obsolete and then you'll struggle to get updated. So, yeah, just like keep looking at all the interesting stuff that is coming out. KubeCon have been an amazing way to like keep yourself up to date on what people are doing, connect with more people, try to contribute if you can. And yeah, like I think it's a very dynamic, very fast-paced moving space. So getting yourself up to date is the only advice I can offer.
Mhm. Yeah, so KubeCon is one thing you mentioned. Is there any other way that you keep track of what's happening? Any source that you go to where you trust that source for the hottest and the up and coming insights and news? Anything you'd care to share?
Yeah, I think podcasts are amazing sources. Interviews like this, if I can get the perspective of people who are working in industry and what they are doing, is an amazing source to see, to validate the ideas, to see like what other people have been successfully doing and successfully migrated to. Yeah, like some of the blogs from companies like Netflix, Uber have been very helpful. And sort of the with the sort of scale that they're operating in, it's always good to see what they are working towards and what they are doing.
All right. Wow. Yeah, that's nice to know that podcasts, are still a good source for you.
It's
Yeah.
an excellent,
Sorry.
I would say like it's an excellent source for me. Like I periodically go through all the podcasts, look at the blogs, look at the news articles. KubeCon happens once in a while, like it's like 6 months.
Yeah. Mm,
If I talk about Europe and North America, like those two are the
mm,
biggest ones. But yeah, like
mm.
podcasts are regular, and like conversations like these are amazing, amazing sources.
Yeah. Yeah, that's true. Wow. Validates what we do and why we do this. So, yeah, it's a good note to end on. But yeah, thanks so much for giving us this time, Rohit. It was really a cool conversation. I feel like we got an in-depth view on just what's happening with Envoy primarily. And we also got a behind the scenes peek into how yeah, the traffic platform team at Databricks functions and how they think through decisions they make and just some of the learnings along the way. And great to see just your involvement in open source, Envoy, Argo, and yeah, looks like you're really in there building stuff, and it was really great to hear from you. Very inspiring. Thanks for joining us. Thanks for sharing all of your insights today.
No, thank you so much for having me. You did send me down the memory lane, so it was very nice just recalling some of the things when we started, how we started, and where we have come. So amazing conversation. Thank you so much.
All right, great. Thanks to all of our listeners and viewers for tuning in. We hope you enjoyed this conversation as much as we did. If you want to continue the conversation with Rohit on anything we spoke, Envoy, Argo, or just life at Databricks, get in touch with him on LinkedIn or elsewhere. And stay tuned to our podcast, subscribe, come back again. We do this about once a week. We upload a new episode. So come back and see what we'll be talking about next week. We'll see you on that episode. Bye bye.